Hi everyone, thank you for joining my video. Today we're going to solve an MAT question 2019, question D from Oxford entrance paper. So this is about integration and we are given two parabolas and there's an intersection here and the area is equal to 9. And what are the possible values of A? So if you want to try it yourself, pause the video and then we could go over it together. So how do we solve this question? Well, if we call this y1 and this is y2, and if you complete the square for y1, you get x plus a squared, that's y1, minus a squared plus a, and y2 is equal to a minus x squared. So if you notice that y2 is simply a transformation of x squared graph, well, minus x squared graph by a. So if we assume, we don't have to make this assumption, but we won't lose any generality by assuming that. If we assume a to be a positive number, so you will have something like this. And then this would be simply shifted to the left by a, and then shifted down by minus a squared plus a. Assuming a is greater than 1, this would be a negative number. I mean, assuming a is between 0 and 1, not between 0 and 1, I meant. Yeah. So you have something like this. Yeah. Or if we said a was, the negative number, you would have something similar to that. Yeah. But we don't need to worry about it much. So let's assume a is a positive number, so we have something like this, and this area here is 9. So how are we going to do this? Well, this is just an integration question, so this is y2 and this function is y1. We need to find the point of intersection. So at those points, y1 is equal to y2, so we have y1 is equal to y2. That implies we have x squared plus 2ax plus a is equal to a minus x squared. Cancel a's. That implies we have 2x squared plus 2ax is equal to 0. X squared plus ax is 0 implies x into x plus a is 0. X is equal to 0 or x is equal to minus a. Okay, so y1, this is supposed to be the origin, and this is minus a. Yeah. Okay, so that doesn't look like an origin because that was a rough sketch, but you get the point. Yeah. Right. So what we want to do is that integrate let's do minus a to a. Let's do y2 minus y1 dx. Okay, so that's equal to that should be 0, sorry. Minus a to 0, not minus a to a. So that would be minus a to 0, a minus x squared, take away x squared minus, plus 2ax plus a with respect to x. And this is equal to 9. Strictly speaking, we don't know whether a is negative or a positive number, so we were supposed to use modulus brackets, and if you look at the mark scheme, that mark scheme uses modulus brackets, which is a more sort of, I don't know if it's a better way of doing it, but it's a good way of doing it. But this way as well, we like to have some freedom to think about the question and use some intuition. Yeah. So a will go with that a. So this will boil down to minus a, 0. We have minus 2x squared minus 2ax dx is equal to 9. That implies minus a to 0, x squared plus ax dx is equal to minus 9 over 2. That's dividing both sides by minus 2. So now let's do the integral. X cubed over 3 plus ax squared over 2 from minus a to 0 is equal to minus 9 over 2. That implies, well, if you plug in 0, you just get 0. take away minus a cube over 3, that's subbing in minus a instead of x, plus a cube over 2 is equal to minus 9 over 2. Let's cancel minuses. So we have minus a cube over 2 plus a cube, sorry, minus a cube over 3 plus a cube over 2. So that will give us a cube over 6. That's equal to 9 over 2. That implies a cube is equal to 27. A is equal to 3. Okay, so a is equal to 3. And if you go back the answers here, so you have that and that, but the answer is a is equal to 3. Now, because we assumed a to be greater than 0, we assumed in fact a to be not only positive but greater than 1 when I was doing this. So that's why we got one value. And if you use modulus brackets, and you would get two values, but you don't really need a modulus argument. You could just use symmetry argument, that it will have to be symmetric if you look at the given polynomials. Therefore, the answer will have to be either plus 3 or minus 3. That will give you the area to be 9. Okay, so this is a bit of loosely solving this question rather than being strict, but more of a 80% of applying rules and 20% of good and educated guess, which is also quite important in mathematics. So I hope you enjoyed it. I hope you found it inspiring, and I look forward to seeing you in my future videos. Thank you.